Unit 9, Section 2, Area of Trapezoids, Kites, and Rhombi. We're going to start this section by finding the area of a state called Nevada. Many of you are familiar with Nevada. That's where Las Vegas is. So I'm going to outline Nevada more or less. Okay, I'm going to copy it. Okay, I'm going to paste it right to the side here. And I'm going to rotate it. Because this is the type of trapezoid you guys are used to seeing. Okay, so I just copied the state of Nevada, and I went ahead and I placed it to the right. And I want to go ahead and put my dimensions. So I go back here. I had a base of 511. So I'm going to go ahead and put that 511 back here. I had another base of 205. Remember, my bases are the parallel lines, right? Okay, so your base are your two lines that are parallel. Obviously, this 309 at the top and the one below it, right down here, are not parallel. So that's how you know those aren't your bases, okay? So to find the area of a trapezoid, we're using a little equation. Area equals 1/2, in parentheses, base 1 plus base 2. It doesn't matter which one we call base 1 and call base 2 here. I'll just call the top one base 1 and the bottom one base 2. And 1/2 base 1 plus base 2 times the height, which in this case my height is 309. So let's start by finding the area of this particular trapezoid. Remember, the area equals 1/2 times base 1, 205, plus base 2, 511, times the height, 309. I like to start doing one thing at a time. We know 1/2 is 0.5, and if we're going to use our calculator, we might as well plug in 0.5 right now. Let's add 205 plus 511. We have 716 times our height, which is 309. So if I multiply all this out on my calculator, I'm just going to do 0.5 times 716 times 309. And I get 110,622. Here we're dealing with miles, as we saw on the previous screen, and it's area, so it's miles squared. So that's the approximate square miles of Nevada. So here's the most important information you need for trapezoid. Trapezoid, you have two parallel sides. Okay. These sides are parallel. These are my bases, base 1 and base 2, and at some point I have a height which forms 90 degrees with the bases, okay, and my equation being 1/2 base 1 plus base 2 times the height. Let's try this. Okay, so we need to find our two parallel lines because those will be our bases, right? So here's a parallel line, here's a parallel line. And our height's the one that forms 90 degrees. There's our 90 degrees right here. 7.36 is the height. The area equation for this trapezoid is going to be 1/2 times, we'll call this base 1, this one base 2. Really doesn't matter though, we can switch those up. 8 plus 17 times the height, 7.36. Notice, didn't need that number 11, don't need this number 7. Let's simplify a few steps here. So we have 1/2 times 0.5 times 25 times 7.36. At this point you can plug it into your calculator. I think you're going to get 92. What are we dealing with here? Meters, and its area, so it's going to be 92 meters squared. Alright, let's say we have another trapezoid here. Let's say we're trying to find the height in this case, and we know the first base is 3.5. Here we have 11.1. This diagonal right here is 9.3, and let's go ahead and say our area is 51.1. Alright, well, we have our two bases, 3.5, 11.1, and our height. Well, we don't know our height. That's what we're solving for. This information we don't need. So our area, 51.1, equals 1/2, or 0.5, times base 1, 3.5, plus base 2, 11.1, times our height, which is what we're trying to solve for in this problem. Let's start working this problem. 51.1 equals 0.5 times 3.5 plus 11.1, 14.6 times the height. 0.5 times 14.6 is going to be 7.3. So I went ahead and multiplied this 0.5 times this 14.6. Still have it times the height. It's still going to equal the area, 51.1. Now I just need to divide both sides by 7.3 because they'll cancel on the right side, get h all by itself. And if I divide that, I get h equals 7. And we're dealing here, let's say we're dealing with centimeters. So we'll call it centimeters. We just found the height. We didn't find the area, so we don't need to square the centimeters. It's just regular centimeters. So let's try to find the area now of kites and rhombuses. In both kite and rhombus, it's really important that we understand the properties of both a kite and a rhombus. Let's first start with the equation. So the equation is 1/2, again, just like the last one, d1, meaning diagonal 1, times diagonal 2. So important to remember the properties of a kite. These are bisected. The left and the right get bisected. The tops are also congruent. Okay, top and the bottoms are congruent. And then also really importantly, because this will help us if we need to use right triangles to solve, we have a bunch of right angles here. Okay, so we just formed 4 right triangles. So that'll be really helpful in helping us solve for missing side lengths. In a rhombus, the diagonals bisect each other. Okay, and then all 4 sides are congruent. You should remember this from semester 1. And lastly, again, just like a kite, we have some right angles here. That'll help us solve in the future. So let's just say we have a side length 8, okay, and a side length of 10. Well, in this diagonal, of course, I know it's split in half, so if that's 10, then the right side's also 10. And this diagonal is also split in half, so if the top's 8, then the bottom's 10. So if we were going to solve for this rhombus, my diagonal 1 would be 8 plus 8, so we'd have the area equals 1/2 or 0.5 times this diagonal, 8 plus 8, 16, times the second diagonal right here, 10 plus 10, which is 20. Okay, so that's how I set that up. And if I go ahead and I solve for that, 0.5 times 16, I'm going to get 160. And I didn't give you units, so we'll just call them units squared. Alright, so at the top of this, notice these are all the shapes that we've covered so far. I'm going to go ahead and give you the equations of each of these. Now, even if I give you the equations for each of these on the mastery checks and on the quizzes and tests, you still have to be able to identify the shape. So, parallelogram, area equals base times height. Triangle, area equals 1/2 base times height. Trapezoid is the first one we started with today. Area equals 1/2 base 1 plus base 2 times the height. And the kite and rhombus that we just did, area equals 1/2 d1 times d2. Alright, let's try this one. We have a rhombus here, so we know that the sides cut each other in half. So my entire diagonal, this whole thing, is 20 and 20. So we're going to go ahead and say our diagonal 1 is 40. And our diagonal 2 gets cut in half, so that's 30 and 30. So our second diagonal is 60. Plug that into the equation. 1/2 d1, which is 40, d2 is 60. So if we go ahead and plug that into my calculator, I'm going to get 1,200 feet squared. Alright, we're going ahead, we're skipping this trig one. I already showed you a kite example in the previous slide, and I haven't shown you how to solve it using trig yet because we haven't learned sine, cosine, and tangent, so we're going to move on for now. Alright, so let's start with this rhombus, and let's say we know this length is 8 and this length is 10. Well, to find my diagonal, my other diagonal, I actually need to know what this value x is. Now, if we remember, they cross and form 90 degrees. We actually have a right triangle here with a hypotenuse 10 and a side length 8. So we need to solve for x. So this is going back to the last unit. X squared plus 8 squared equals 10 squared x squared plus 64 equals 100. Leaves us with x squared equals 36 and x equals 6. Alright, so I know that this top portion right here is 6, which makes this bottom portion also 6, and if the right side was 8, then this left side is 8 as well. So my first diagonal, 6 plus 6, is 12. My second diagonal, 8 plus 8, is 16. Now I can go ahead and solve for the area of this rhombus. So area equals 1/2 or 0.5. 0.5 times 12 times 16. Plug that into your calculator. You're going to get the area equals 96. And let's just say here we're dealing with inches. We've got 96 square inches is the area of that rhombus. Alright, let's take a look at this kite. Notice a 30 degrees, so that's going to be our hint because we don't know either diagonal. We don't know this diagonal, and we don't know the other diagonal across here, the one I just did in purple. So let's start with our 30, 60, 90 triangle. Draw that to the side. That was a poor drawing. Let's try this again. And we have our 90 degrees here, and our 30 degrees here, and our 10 here. So for those of you who are used to starting with the shortcut method, it might be useful to set up a similar triangle to start. Alright, same thing, except we have our 1, √3, and 2. We really need to solve for both. So we need to solve for, let's just call this x, and let's go ahead and call this y. So solving for x first, remember our scale is 10/2 equals x/1. Cross multiply, 10 equals 2x. Divide by 2, x equals 5. So that was an easy one. So we know right here we have x equals 5. And let's go ahead and look at the bottom part down here. We know that we have 10/2 equals y/√3. Cross multiply, 10√3 equals 2y. Divide by 2, 5√3 equals y. So now we know 5√3, left side's the same as the right, so we have 5√3 here, but turns out we're actually still missing this part right here, because in a kite, it's not cut evenly in both diagonals, only one diagonal. So we actually need to solve for this guy right here. Oh, sorry, actually, I see we have 18. We don't even need to solve for that guy right there. So we know our one diagonal, that whole long line, 18 plus 5, 23 centimeters. Our second diagonal is 5√3 plus 5√3. Okay, so we haven't done a ton of adding radicals lately, so let's make sure we remember that the numbers add, but the radicals don't add. So our second diagonal is 10√3. Alright, so our area then is 1/2 times our first diagonal, 23, times our second diagonal, 10√3. Final step, 0.5 times 23 times 10√3. Remember, this guy, he kind of gets dragged along, but I can go ahead and multiply 0.5 times 23 times 10 and get 110, and then this radical 3 kind of gets dragged along. Oh, user error. 115, not 110. Plugged it into my calculator wrong. 115 radical 3 centimeters squared is our area for that kite. Alright, that concludes the unit. We've talked about area of rhombuses, kites, and trapezoids.